Hello primary 4 students, how are you? Welcome in your science class with me, Dr. Shaimaa Hamdy Kassem, and your channel, the Big Testers channel. As now, we will study lesson 2 from concept 1, unit 2. So, let's start. Here we have activity 4. We already know that force means a push that to move the thing away from you, or pull, which move the object towards you. So force is a push or pull that applied to an object causes it to change its position. Change its position means that object moves, okay? So again, force means a push or pull that applied to an object causes it to change its position. We know that the object can't move or stop without force. So here, when there is a force applied on an object, so the object can move or change its position. So we have a question here. How do objects move? So there are two forces that cause the objects to move. Pushing force, as this picture, a man pushes a wheelbarrow. Okay, so here the man moves this wheelbarrow away from him. So this is pushing force. And we have another type of forces, which is pulling force, as here in this, the child pulls a toy car as it moves the toy car toward him. So now we have question. This boy is applying pulling force or pushing force? Yes, this boy is applying pushing force because he moves this card away from him. So, well done. This is when an object is affected by one force, even pulling force or pushing force. What about if this object is affected by two forces at the same time? Okay, so we have an object that two forces applied on it. Even these two forces are two pushing force in the opposite direction or pulling forces in the opposite direction. We will see what will happen for this object. Will it move or it will not move? So we have here a box that is affected by two pushing force. They are in the opposite direction and they are with the same amount. They are equal. Does this box will move? The answer will be no. This box doesn't move. Why? Because the two forces are the same amount and in the opposite direction. This is called balanced force. Balanced force. Also, if the box is affected by two pulling force with the same amount, they are equal and they are in the opposite direction. So here, this box will not move. So if the forces, even they are pushing forces or pulling forces, but they are equal to each other and in the opposite direction, so the object will not move. And this is called balanced forces. But here, the object is affected by two forces. They aren't equal, as one force is greater than the other force, and the two forces are in the opposite direction. So here, the object will move because the forces aren't equal. And we call the forces that aren't equal and in opposite direction, we call them unbalanced forces. Unbalanced forces, the opposite of the word balanced. Okay? So simply, the object will not move if it is affected by balanced forces, as the forces are equal and in opposite direction. And the object will move if it is affected by unbalanced forces, as the two forces aren't equal. One is greater than the other and both of them in opposite direction. And we will apply this information on the game that called tug of war game. Did you play this game before? Yes. So the tug of war game, here the rope is affected by two pulling forces, as we have two teams and the two teams pull the rope, so the rope is affected by two pulling forces. So if these forces are equal, and for sure they are in the opposite direction, so here the rope will not move, it doesn't move, okay? But if, as we see here, these two teams apply different pulling forces, as one of the pulling forces is greater than the other and they are in opposite direction, so the rope will move toward the greater force. Okay, so here the rope will move toward the greater force, and this is logic. So we can summarize that as we have, if the object is affected by two forces, so the forces may be balanced forces or unbalanced forces. Balanced forces act on an object so the object doesn't move, as we saw in the tug of war game. If the two teams are pulling the rope with equal forces, this is called balanced, so the rope will not move. But in the unbalanced forces, they act on the object, so the object will move. And here, if one team is pulling the rope with greater force, so the rope will move toward the greater force. We have activity 5, objects in motion. What the meaning of the word motion? Yes, it's changing the position. That means the object moves. If the object changes its position from one place to another, this is called motion. Okay, so even this motion can't be seen, as we can't see the Earth planet when it moves around the sun, but we know that this is motion. So also the moon, it moves around the Earth. We can't see this motion, but we know that the moon moves because it changed its position. So this is the meaning of even this change can't be seen. Those are examples for this. The motion that can't be seen. So to prove that an object is moving, we can compare its place, its position with a fixed point, something that doesn't change. As here, this tree. This tree is a fixed point because it can't change its position. So as we see here, the ball was in position A, near to the tree, and it moves to position B. So we can compare the change in position by using this fixed point, which is a tree. So the change in a position of an object is compared to something else that is usually doesn't move, like, and this is called fixed point. As in this picture, we can compare the position of any object with a fixed point. Like here, we have tree, we have lake, those are fixed point because they don't change their position. So we can compare that this girl is beside the lake May when she walks. So we can compare the change of her position to the fixed point, which is the lake, or another example, the tree. Okay, so we can define now motion. It is any change in the position of an object relative to a fixed starting point. And here we have an example. Here, these two boys are playing with this ball, and there is a fixed starting point like this tree. As this boy throw the ball, so he applies pushing force for this ball, so it moves toward the second boy, and we observed that the ball falls onto the ground, and we will know why. And then the second boy pushes against the ball to make it stop. So here it looks like the goalkeeper when it pushes against, because his direction is opposite to the ball, so he is applying pushing force, pushed against the ball. So while the boys are playing with this ball, we can compare the change of the position of the ball relative to the fixed starting point, the tree. As the ball is near to the fixed starting point, and the ball changes its position to another place from the fixed starting point, which is the tree. So, okay, we mentioned that the ball falls down to the ground. So, what is the reason? The reason because there is a gravity force. Gravity force, this is a force that pulls objects, all objects toward the earth or toward the ground, okay? As this force is affecting all objects on earth, as this force makes us stand on the ground. So here we have a very important force which is called gravity force, and this force is a pulling force. This is very important information. So gravity force, it pulls all objects toward the ground or earth. Here we have some motions that are easy to be seen, like walking people, like the leaves move by the wind blowing. When the wind blows, the leaves of trees, so the leaves move. Those are examples for motions that are easy for us to see. But there are some motions that are hard to be seen, like the rotation of Earth around the sun, as we mentioned. So here, this is an example for motions that we can't see, like rotation. It comes from the verb rotate, which means move around. So rotation of Earth around the sun is example for motions that we can't see. Here we have activity 6, force. As we learned, any object needs force to move and change its position. So force, it is a push or pull that is applied on an object, causes it change its position. So here we have some examples, and we will see the forces that affect this object, okay? As here we have this girl is pulling her bag, okay? So she applies pulling force by her arms, and we studied that there is pulling force of the gravity, and those forces are in the opposite direction. So as the girl pulling the bag, so that means that the bag, this is the object, moves toward the greater force. Yes? So here we conclude that these two forces, the pulling force by the arms and the pulling force of the gravity, are unbalanced forces, and the bag moves up toward the greater force, which is the force that applied by the girl's arm. Okay, so again, with this boy, he is holding the bag, so that means that he applies pulling force by his arm, and there is a pulling force of the gravity, so those forces are unbalanced because the boy already holds the bag. That means that the bag moves toward the greater force, and the greater force is the pulling force by his arm. So here, what do you think? This boy wants to carry this box from the ground. Okay, so to move up this box from the ground, it needs what? Yes, pulling force that applied by this boy. And already this box is affected by the gravity force that pulls all objects toward the ground. So here, for this boy to carry this box, he must have a pulling force because he moves the box towards him. So he must apply pulling force which is greater than the gravity force, so he can move the box up. Okay, those are examples for unbalanced forces. The two forces aren't equal. So if we have an object that it doesn't in motion, it doesn't move, so what is the forces that applied on this object? We will see now some examples. Here, when you sit on a chair like that, so we already know that there is force that pulls any objects, even people or any objects around us. There is a force that pulls all objects toward the ground, and this is pulling force. But here, as you sit and don't move toward the ground, that means that there is force which is in the opposite direction, okay, equals to the gravity. So here we have balanced forces. Yes? Okay, so here this force is the force of the chair, as the chair applies force to push you upward. So this is to push you upward. Okay, so here this pushing force upward for the chair and the pulling force to the ground of the gravity are balanced. You sit on the chair without motion. As here for fun, Donald Duck sits on broken chair. So here the chair can't exert pushing force upward to Donald Duck. So the greater force here is the gravity force. So it pulls him toward the ground and he falls on the ground. Here we have the last example for an object that doesn't in motion because it is affected by two balanced forces. At this book on the table, it is affected by the gravity force which pulls it toward the ground, and also it is affected by pushing force pushes upward of the table. So those are two equal forces, balanced forces, so the book isn't in motion. Okay, with this information we finished our lesson, so don't forget to subscribe, like and share my channel. Thank you for watching. See you next video inshallah, and goodbye.